Within a decade, there'll be 100 billion devices connected to each other. There are estimates that by 2025, there will be a $6.5 trillion economy just around the Internet of Things.
What we're seeing is a merging of the software and the physical devices coming together. The electrical sensors, the electromechanical sensors, the material-based sensors, then creating data that can be used for connectivity and for control. And so engineering in many ways is going to be core to the benefits we're anticipating from the Internet of Things.
McMaster Engineering is future-focused. Our focus is on making cities smart. We, therefore, have a major focus on smart systems.
Engineers will play a pivotal role in outlining for society what are the opportunities and what are the costs associated with really radical new ways to deliver healthcare, to transport goods, to create and use energy.
Cities of the future will involve interconnected systems with a number of different facets involving sensors, advanced analytics, and coordination between these different subsystems. It's within this coordination aspect where we focus.
Primary goal for this research is to look into integrating information that we develop and generate as engineers and putting it into decision support system tools. We are trying to create a resilient city that can withstand certain natural events and natural disaster as well as technological disasters as well.
Our goal is to be able to give people the tools to know if the water that they are about to drink is contaminated and potentially causing disease, if the food that they are about to eat is also contaminated with bacteria, which will cause disease.
There are still 2 billion people worldwide without access to safe drinking water. Using smartphone technologies, we have students going out into even very remote communities and remote places to log GPS coordinates together with the water situation in these different places.
I work on harvesting lost heat from commercial to industrial applications to energy generation technologies. We change that waste heat to electricity, store it in thermal batteries, and we're developing technologies that can control and automate that system.
My research is really about what evidence you should produce in order to be able to claim the safety, security of a safety-critical, software-intensive system.
Right now, we're developing and testing high-tech, smart and sensor-based solutions to help save lives in construction work zone by detecting nearby hazards around workers, equipment operators, and the vehicle around work zone.
We're developing technologies that will enable the cities of the future to view water and wastewater treatment not as a liability, but as a resource facility. And we are applying new technologies like recuperative thickening that will enable cities to triple the capacity of their existing treatment facilities. The energy that will be produced from those facilities will be more than what is actually needed to run them.
One of the unique aspects of McMaster Engineering is that we are constantly looking for opportunities to bring our undergraduates into our research activities so that we can help train them in the context of state-of-the-art problems and evolving the solution to those state-of-the-art problems.
McMaster provided me with the right toolkit to be a problem solver, to take messy, complex situations, and then to find optimal solutions to those problems. As the world gets more complex and gets more interconnected, the premium will be on students and graduates who can, in fact, continuously learn and keep learning all the changes that are going on.
Our students are developing the transdisciplinary skills required to be able to first use this cutting-edge technology and then apply it in various contexts.
We really need to show them that they are not a unique discipline, they are not on silos onto themselves. They really need to integrate and interact with other disciplines as well. Engineers will have to work with social scientists, for instance, in order to come up with unique solutions that are really meaningful to the community.
We have lots of opportunities for the students to go and work on these integrated collaborative teams. So I've currently got 7 students that are going to Chrysler this summer. They're going to work with mechanical engineers, electrical engineers, software engineers, control engineers.
As part of my master's and now my PhD, I've been getting hands-on experience working on the actual software which is inside Chrysler's vehicles. I've been able to look at what they have, interface with it, and in my research what I've been doing is refactoring their designs. A few of my designs have been used actually in production code when it comes to Chrysler's vehicles. Interfacing with an automotive partner, I can see how their developers work on a day-to-day basis, and I can take that and kind of integrate it into my work process, get a better idea as to what going out in industry actually entails.
I work with Siemens Canada on strategy. There's a big push towards the Industry 4.0 and the Internet of Things, and our technology has a big role to play there, and we're hoping that we can work with McMaster's faculty and students to really kind of develop those concepts and make them become a reality.
What we're creating with our programs is we're creating engineers that understand both the physical side of the world, the continuous dynamics, and the cyber side, software-oriented part, and how those two interact to create the systems of the future.